In a series LCR circuit, the resonant frequency is 800 Hz. The half power points obtained at the frequencies of 745 and 855 Hz. Calculate the Q factor and also the bandwidth. So we know that omega, which is equal to 2 pi f. Omega resonance frequency omega r, which is equal to 2 pi fr. So the resonance frequency given, the first frequency and second frequency it is given. So Q is equal to omega r, omega 2 minus omega 1. Instead of omega you have to substitute 2 pi f. Taken 2 pi commonly outside, get cancelled. Then resonance frequency, which is equal to f2 minus divided by f2 minus f1. So substitute fr value, that is the resonance frequency value, and second frequency value and first frequency, second half value and first half value. We get an answer 7.27 is the Q factor of this LCR circuit. Then the bandwidth is very simple, omega 2 minus omega 1, that is f2 minus f1, which is equal to 855 minus 745, which is given here itself, 110 Hz, that is 100 Hz. 10 Hz. So in this LCR circuit, this problem explains about Q factor, power factor of the LCR circuit. Now we are going to see a problem based on transformer. The primary coil of an ideal step-up transformer has 100 turns. So primary coil 100 turns and the transformation ratio is also 100. Input voltage and power is 220 voltage and 110 watt. So input power means input power is E1, input voltage is E1 and input power is P1. So as it is given value N1, which is equal to number of turns in the primary coil 100, and input EMF in the primary coil is E1, and input power in the primary coil is 1100 watt. Very simple, students. The transformation ratio means this is a transformer equations, transformer formula. E2 by E1, which is equal to N2 by N1, which is equal to I1 by I2, which is equal to transformation ratio, transformer ratio or transformation ratio. So you have to remember this equation for solving this problem. So transformation ratio K is equal to N2 by N1. N2 is a secondary coil turns and N1 is a primary coil turns. The question is, calculate the number of turns in the secondary coil, keep N2 as it is, bring the N1 here, we get an answer N2 is equal to 10,000 turns. So for step-up transformer, primary coil turns must be less than that of the secondary coil turns. So primary coil is 100 and secondary coil is 10,000 here. So it is a step-up transformer. Then what is the current in the primary coil? Again, power is given E1, that is power P is equal to VI. So power in the primary coil, which is equal to voltage into current, then voltage EMF is E1 into I1, then I1 is equal to P1 by E1. So already it is given in the question itself, power in the primary coil is 1100 watt and voltage is 220, we get 5 ampere. Then calculate the voltage across the secondary coil. So keep these formulas, remember. So E2 by E1, which is equal to K. So E2 as it is, bring the E1 here, we get an answer 22,000 voltage. So the input voltage is 220, then output voltage is 22,000 voltage, hence it is a step-up transformer. Then what is the current in the secondary coil? Again the same equation, K is equal to I1 by I2. Listen students, E2 by E1, N2 by N1, but current alone I1 by I2. Okay, so I1 by I2, bring the I2 here, I2 as it is, and I1 by K, which is equal to, what is the secondary coil current? 0.05 ampere. Then power in the secondary coil is, output power is equal to input power. Always the power will be same. So output power is equal to input power. 1100 watt is a power in the secondary coil. So this equation, this problem 5 will explain clearly about the transformer based questions. The next question also based on the transformer. So calculate the current drawn by the primary of a transformer which steps down 200 voltage to 20 voltage. So primary coil voltage is 200 and secondary coil voltage is 20. To operate the device resistance is 20 ohm. That is a secondary coil resistance is 20. So assume that the efficiency is 80%. So E1 is given, E2 is given, R2 is given, then the efficiency is given. So E2 is equal to voltage is equal to V is equal to IR. So E2 is equal to I2R. Then I2 is equal to E2 by R. We get 20 by 20, 1 ampere. So current in the secondary coil is 1 ampere. So efficiency which is equal to output power by input power. Output power is E2 into I2, then input power is E1 into I1, then I1 only we need. So efficiency value is 80%, so 80 by 100. Substituting these values, we can calculate I1 is equal to 0.125 ampere. So this is a very simple transformer based problem which you, by using the efficiency of the transformer. The next one is, now we are going to see the problem based on generator. An AC generator consists of a coil of 50 turns. So number of turns in the coil 50. The area is 2.5 meter square. It will rotate with the angular speed of omega is 60. Then with the magnetic field is B is equal to 0.30 Tesla between the poles of the magnet. The resistance of the coil also given as a 500 ohm. So what is the question? What is the maximum current drawn from the generator? So what is the maximum current means? N is given, A, omega, B and R is given. So maximum current I0, that is the amplitude peak value of the current I0 is equal to E0 by R. So E0 value is NBA omega. Then we get R substituting here, we get an answer I0 which is equal to 4.5 ampere. So the maximum current in this generator produced by this generator is 4.5 ampere. Then next one is, what is the flux through the coil when current is 0, when current is maximum? So we know that pi is equal to NBA cos omega t. So if you want the EMF means differentiating the d pi by dt, that is a flux. If you differentiate the flux, change in flux with respect to time is a EMF. So if you differentiating this equation, we get NBA omega sin omega t is a E0 value. So that is the E value which is equal to NBA omega sin omega t. Okay. So this is a E. So NBA omega is a E0. So I is equal to E0 by R. That is the I0 value. What is we are seeing in the first subdivision. So sin omega t. So NBA omega by R is a I0. So I0 is equal to E0 by R. So these are all the equations. Keep in your mind. So what is the question given? What is the flux value when the current is 0? If the current value I is equal to 0, you put I is equal to 0, then I0 sin omega t. 0 is equal to I0 sin omega t. This I0 also comes to the denominator 0. So when the sine angle will be 0, then sin 0 is 0. So when the angle is 0 means answer is 0. So omega t must be 0 degree. So for cos pi you have to substitute for omega t 0 degree. Cos 0 degree 1. So the flux will be maximum. We can calculate the maximum flux as 50 into 0.30 is the magnetic field value and 2.5 is the area value. Magnetic flux value we can calculate. So when the current is 0, the magnetic flux is maximum. When the current is maximum, what will happen? When I is maximum means this sin theta must be equal to 90 degree. So this will be current maximum means one value. When it will come on omega t is equal to 90 degree, substitute in the pi value, flux value NBA cos omega t is a 90 degree. What is the cos 90 degree? 0. So when the current is maximum, the flux will be minimum. That is the flux will be 0. So please dear students, understand the problems based on this AC generator, that is a generator based question, and also transformation action, that is a transformer question. For the transformer question, this equation is very important. This is a formula for transformer. Also in this sessions we are seeing the LCR circuit based problems also. Thank you students.